So, hi everyone, and thank you so much for coming to this presentation tonight. I appreciate it. It's definitely into beer o'clock at this point, so thank you for being here. And we've got a presentation on dangers of a service as a principle in Amazon Web Services, or AWS for short. But before we dive in, just a quick introduction. So, hello, my name is Matt. I'm a security consultant at WithSecure, mainly focused on the cloud. I started off about 8 years ago as a support analyst in a sort of logistics IT company, and I was exposed to AWS there. And I took up a role with the SysOps team, and yeah, basically just fell in love with all things AWS. And I'm joined by my colleague tonight, Tom.
Hi, and yep, I'm Tom. As you can see, I'm mostly network security and also AWS cloud security. And I used to work in aviation, so yeah, dabbled about with the cloud, but I've been working at WithSecure for sort of almost a couple of years, and this is my main cloud experience.
Awesome. Thanks, Tom. So, what to expect from this talk? Well, as we've kind of already discussed, it's going to be based on AWS and specifically something known as resource-based policies, and we'll dive into specifically what they are further in the deck, and specifically how we as WithSecure started noticing a certain pattern within our cloud estate, which led us to do some research on resource-based policies, and how we kind of developed sort of an attack path, so to speak, that we published some research on. And yeah, we're going to give a full demo of how an attacker might actually use this and how to defend against it ultimately. And the good news is, even if you've never seen AWS or a resource-based policy before, this presentation should still make sense. But before we dive into actually the attack, we just need to make sure we understand what a policy in AWS actually is. So policies form part of the IAM service, which stands for Identity and Access Management, and this effectively controls everything in AWS, who can and can't do specific actions, for example. So if we break down the example that we have on screen, you can kind of see that the middle section, there's an action, S3 create bucket. For those that have not heard of S3 before, it's just a medium of storing basically anything within AWS. And the effect is allow on resource star and the principal star, and the two stars are just a wildcard in AWS. So the easiest way to break down this policy into a sort of a one-liner is it allows anybody to create an S3 bucket, for example. But how would it actually work in practice? Well, let's say we have a user called Tracy, and they want to create an S3 bucket. So on the first screenshot on the left, we can see that they send a command to the AWS APIs saying create bucket. The -- bucket flag of my bucket is just the name. A region, this is just defining where the bucket's going to live. And finally, the object ownership flag, which is just ensuring that anything that's uploaded to that bucket will be owned by Tracy in this case. Once she submits that request, the AWS will evaluate the policy that we looked at earlier, and in turn, this will be allowed because we already know that the policy is allowed to create S3 buckets. And the API will respond with location my bucket, and this just effectively means it was successful because it's just re-outputting the name that she originally requested it to be called. Okay, so where are policies used in AWS? Well, everywhere, hopefully. So they can be used to be set against users, for example, or any form of entity, roles, resources as well, such as servers or something like similar, which is what we're referring to with resource-based policies. So the core thing to take away from this slide is just that policies are effectively everywhere in AWS, and it's impossible to kind of use AWS without interacting with policies in some way. And as we mentioned, there's also something known as resource-based policies. Now, these are something that takes a slightly different approach from the one that we just saw, where Tracy wanted to create an S3 bucket, whereas a resource-based policy is applied against a specific resource, as you might expect. So if we were thinking about the S3 bucket that we just created, for example, we may assign a resource-based policy to it that allows someone to upload a file or to see that bucket. So the policy isn't actually assigned against a user or an entity, it's assigned against the actual resource. And now Tom's going to walk through how they're used.
Yeah, thanks. So, yeah, resource-based policies then are used on lots of services in AWS. We've listed a few of them there, but there's 200 services or so in AWS, and quite a lot of them use resource-based policies. The ones we've put up here mostly are just because they're going to come up later in the presentation. Not going to walk through all them all at this point. We'll get to them as they come up. But what do they have in common? Well, it turns out that these resources are all deployed in AWS managed areas of the cloud, so you can get to them from anywhere within the AWS network. And whereas a user-based policy or a service-based policy defines what a particular entity can do, just to reiterate what Matt said, the resource-based policies sort of flip that logic, and they go, okay, if I take all of the entities in AWS, who am I going to allow to access this? Also, what happens then if you don't set a resource-based policy? Well, here's a diagram from AWS which starts explaining it. And AWS IAM is quite difficult. There's a lot of stuff that's involved in it. So we've just highlighted the little bit that we are particularly interested in. And you can see straight away, if there is no resource-based policy, it will just carry on and go through the rest of the flowchart. If there is, it goes into a see the resource-based policies section. That gets a little bit complex, but it will evaluate the resource-based policy and figure out whether your user or entity has the ability to do what you like. What this means for us really is that there's no detriment really from not having a resource-based policy set, but if you do set them, you can improve your security posture further and have more fine-grained controls. I'm going to look at a couple of common misconfigurations. Now, these are things that are fairly well documented. AWS I've written a lot about them, loads of stuff on the internet about these, and they're the sort of things that people you'd hope would be aware of if they're operating in the cloud environment. So this one is not adhering to the principle of least privilege. And what's the problem? Well, that action is part of the policy, says S3 action star. And again, the star is a wildcard, so this is basically saying that the principal, which is that reader role, has privileges to do anything it likes in S3. So it can read stuff, but it can also write stuff out of the bucket, can modify the bucket configuration. And so say you've got an insider threat who's been assigned this role, or there's an attacker who's laterally moved and assumed it, they could do whatever they like. They could make the bucket public, they could just read all our data, or add new and fictitious data into our bucket. So this is bad. We've also got another common misconfiguration, which is opening access up too widely. So here you'll see we've got the principal is AWS star, and like Matt said earlier, this means that anyone within AWS can perform the S3 get object action on our resource. So this, again, could lead to data breaches, and effectively here you've made your bucket public. So I'll hand back over to Matt to talk about what we were looking to.
Perfect. Thanks, Tom. Where do we actually start with all this? Like, where did this all begin? Well, something that we do at Wish Secure, we look at clients' AWS estates and help them make them more secure, right? And we started to notice an occurring pattern that people were sort of inherently trusting other AWS services as part of their resource-based policy, which started to get us thinking, well, if it's just trusting a service, that service is effectively available to everybody, right? So can we maybe be in a position where we can interact with something within somebody else's AWS account just because they've trusted another AWS service that we also happen to have access to? And just on that point, we do have to ask ourselves, is the cloud private? Well, you first think, well, it's a shared service, right? So of course, no. But when you start architecting with the cloud, you can fall into a kind of position and a space where you put this virtual kind of block around your estate, and you think that it's nice and secure just because it's yours, right? Like no one else can interact with my resources unless I give a specific permission to do that. But yeah, we all have to kind of take a step back from that and remember that everything is shared, and at the end of the day, we are all hitting the same APIs of said cloud provider, just with a different set of parameters. So what would a real-world example of this actually look like? So for this demonstration, we're going to use S3, which we've kind of already covered. It's just a storage medium, sending a message to something known as an SNS topic, which just stands for Simple Notification Service, whenever a certain event happens. So yeah, so say, for example, like we want an alert to trigger when a file is uploaded to S3 to send an email, maybe. So that's the example we're going to go through. So first, we have to have a look at the resource-based policy that's applied to the SNS topic. And in this case, we can see around about in the middle of the screen where it says principal service, S3 Amazon AWS.com, and then just a little bit below, action SNS publish on resource star. That effectively means that S3 as the service is being trusted with this specific action. So S3 is allowed to publish a message to this SNS topic. So yeah, as we've kind of previously discussed, S3 has the ability to send events to SNS when something happens. So in our case now, we're going to configure it so that whenever a file is put into an S3 bucket, in other words, uploaded, we want to trigger a message out to SNS in this case. Now, on the right-hand side, we're just configuring the destination of that event to happen, and we've specified the ARN of the SNS topic. And the ARN just stands for Amazon Resource Name, and that's something that every single resource within Amazon is granted. So it's kind of a way of thinking about it like a URL. It's kind of what it is. It's just a way of pointing to a specific resource within AWS. So now that we upload a file to the S3 bucket, this is the kind of email that we're going to receive. And although it looks a bit jargony right now, if you kind of break that down, it will just confirm like the file that was uploaded, who uploaded it, the IP address that they came from, all the kind of things you'd want in an event notification of a file being uploaded, right? So this all looks good. Everything's working. Yeah, like this is exactly how we want our event to work. But now we're going to change AWS account. So we're going to switch into an attacker-controlled AWS account. Now, for whatever means, this may be sort of an internal threat, or if someone has been able to sort of hack into your AWS account, someone has been able to figure out that that resource-based policy exists on that SNS topic, and because of that, they now know the ARN of such SNS topic. So what the attacker will do now is create the exact same event notification configuration, but they will now do that in their account. And as we can see from the screenshot on the right, it's kind of the exact same configuration again with placing the ARN of the SNS topic, but now this is in the previous account that we were looking at. And as soon as the attacker uploads a file to an S3 bucket that they control, surprise, surprise, the event gets triggered, which yeah, take it how you will. But I'm pretty sure that the sort of owners of the original SNS topic probably didn't intend for this sort of notification functionality to take place. And what's really, really key from this is that the event actually originated from an attacker-controlled AWS account. That's the key thing. This would be a really good time for PowerPoint to freeze. There we go. OK, sorry about that. So yeah, you may be asking yourself, sort of, what's the further impact of this? Well, as we were kind of saying, so an attacker has now been able to interact with a resource that was in a completely different account from theirs just by a badly configured resource-based policy. And what's really key about this example in particular is that SNS as a service, there's no way to kind of put a network barrier around it. It's just available as part of AWS. There's no way to isolate it at all. So as long as this misconfiguration within AWS exists, you effectively, in a way, expose your resources to the internet, but it may not be very clear that you're actually doing that. And SNS as well doesn't just have the capability to send emails, it can also send things like HTTP messages to sort of webhooks, or SMS messages, so there's always the option of phishing, or if it's involved in some kind of automation process, you can potentially mess with it in that way to cause impact. So Tom's going to give some examples of where else this could be used in AWS as well.
Thanks. So yeah, before we move on to this second example, just going to give you a little bit of context behind the services, because we said at the beginning you don't need to know AWS for this. So first up is Lambda. If you've heard of this, it's probably one of the more recognizable AWS services, and it'll allow you to write code, run it in the cloud in one of several programming languages. It's serverless to the end user, so you can just sort of set your code to go and AWS will run it for you. And if two AWS services exist, they don't really interface how you want them to. You can use Lambda and sort of make your own code to do that. Importantly for us here, when you run a Lambda, it runs on AWS managed infrastructure. And if you've got your own little specific private area of the cloud known as a VPC, you can attach that Lambda to your VPC and it can then access and interact with the resources within it. We've also got API Gateway, which is Application Programming Interface Gateway, and that's what AWS call it. And there's a couple of examples here that we've put in. The one that we're going to look at specifically is, say, that second one, where you might have an internally hosted gateway, and you're going to give developers, let developers hit it, and they'll get time-limited credentials to interact with a different system. Obviously, for each of the two examples, the policies in place are going to be pretty different due to unique access requirements for each of them. So we took a case where we see services often working together. So we've got a Lambda function here, which is invoked by an API gateway. So you can see, again, in the principal section, we've got a service which is API gateway, and the action is to Lambda invoke function. Now, you will probably at this point be able to see the problem with this, that it's saying service API gateway is allowed to interact with a Lambda, but it doesn't specify whose API gateway can do so. So to quickly show how this works, got our intended functionality. So if we follow the arrows, we've got API gateway calls the Lambda function. The Lambda function then goes into secrets manager, which is what it sounds like, and gets a secret out, say a password. Returns that to the Lambda function, which then comes back to the API gateway and presents it to the user. So as we move on to the next slide, keep an eye out on the 4 points on the right-hand side of the slide to see how they change when we're doing our theoretical attack. You see nothing has changed, because this is intended functionality. The only thing that's changed really is that we are making the API gateway call from our own account. So theoretically that should work, but we wanted to test this, of course. So we set up a Lambda function with the resource-based policy that we showed you earlier. And the function of this was just to go into Secrets Manager, take out a secret, and then return it to us. And yeah, is it an unusual scenario? Possibly not. It's sort of a fairly standard use for API gateway and interacting with Lambda. And what we wanted to do is show that it will get this secret for you, but also that if you provided particular inputs to a Lambda function, we just added something that will return those inputs to you to demonstrate that we can do other things as well as just pulling out secrets. So here's the attack. Quite simple in the end. We just go to the API gateway that we've set up, and it's interacting with a Lambda. And you can see in there, it's pulling out our secret data. And also, if you look in the bottom right, we've got the request that we sent it, and it's given that back to us in the data area. So this means that if we've got any idea about the structure of the data that should be sent to the target Lambda function, we can just replicate that in our request, and we'll interact with the Lambda in the way that a developer never really intended. So you may ask, I said earlier, there's the 200 or so services. We didn't look at all of these, of course. But for those who know AWS, you might say, well, okay, EC2, you can control operating system calls on that. You've got loads of control over it. Surely we can do an attack with that. And in fact, the answer is no, because although we have more control over the EC2 instance itself, we have less control over what the EC2 service can do. And it's what the service, or what we can get the service to do, which is the important thing here. As an example of this, when you set up an EC2, you actually have to assign it a particular role. And we've got an example one on there. And that's the thing that is then making all of the API calls. this is not the service EC2 Amazon AWS.com, which means that any attack that we just demonstrated would fail from it. So there's a very limited set of services that this will actually work from. So yeah, many AWS services work in this way. API Gateway is notable, and what we focused on because it doesn't. And so the API Gateway service is the thing that's actually making all of the calls, which is why the attack for us using API Gateway is so controllable. And so, yeah, back to Matt for prevention.
Perfect. Thanks, Tom. So yeah, you may be looking at this and thinking, well, it's a cool attack, but how would I actually look about preventing something like this? So how would I stop this sort of abuse of resource-based policies taking place? And the key is actually something known as source checks, and they are a way to effectively ensure who is making the request to interact with that service in some way is someone that you actually expect. And just to give an example of this, so this is an SNS policy, resource-based policy, sorry, that we were looking at before, whereas instead of it just being open to a specific service, we now have a section on the bottom, the condition section, where we are saying the string equals AWS source owner, and if that black box wouldn't be there, a full sort of AWS account number would be there. So now, whenever a request is sent to that SNS service, there's going to be an additional check to validate which AWS account is making that call, and ensuring that it is either your own or at least one that you inherently expect to be making a call to this SNS topic. Just a quick note on the bit at the top as well. So even though the principal is AWS star, you may be looking at this thinking, hang on a sec, doesn't that still allow anybody to effectively interact with this SNS topic? So no, the conditional check at the bottom will kind of take priority over the wildcard at the top. Further reading. So we do appreciate that this is kind of like quite a lot to take down in one quick talk. So we do have a blog that we published on the WithSecure Lab site about this. If you want to see some more kind of technical details and have a mess with the policies yourself in AWS maybe. We also want to give a shout out to Datadog as they released a paper which was also touching on a very similar trust-based, resource-based policy kind of issue within the AWS AppSync service. And yeah, there's a link to that in the slides as well. So key takeaways from this. Well, number one is automated tooling isn't really available to kind of detect this issue at the minute. IAM is quite a hard thing to get right in the cloud, and automation isn't always does a good job at that either. So definitely one to watch out for. In regards to sort of documentation from AWS as well, that is also a bit inconsistent. So depending on the service that you're actually looking at, there may be warnings about this, there may be not. Specifically, for example, if you try and configure this like misconfigured resource-based policy in the console, you may get a warning in some screens, whereas if you use the CLI, you'll get no warning at all. So don't rely on the documentation from the cloud provider. And whenever you do create resource-based policies, ensure you know who you're giving permission to. So don't trust any defaults, and just ensure if you are trusting a specific service, for example, ensure that there's an extra check on there just to make sure that nobody that you don't intend to interact with that will be able to. Wherever possible, try and think about this in the design phase. It's obviously a lot easier to fix this when it comes up in a sort of pre-assessment phase than it is after it's already been deployed to production, and then there's 100 change requests to get through, et cetera, et cetera. So always try and think about these things before you actually push stuff into AWS. And yeah, don't also assume that AWS has you covered. For example, if you put this like into your account, they're not going to do anything to kind of warn you about it or stop, you know, an attack from it sort of happening. So yeah, that's kind of on you. And just a final note that AWS are actually aware of this issue internally, and they are working on some prevention methods. What they are going to be, we don't really know yet, but yeah, they are aware of it and they are working on a solution. So just to note, if anyone does have any questions, we'll kind of be available and around after the presentation. So yeah, just feel free to grab us and ask any kind of questions you've got. And also just to reinstate, there is the WithSecure Labs post as well. But any questions, do feel free to ask. And with that, thank you so much for listening.
Thank you.